AI for doing better coding, but this morning we are going to look at the univariate statistics as well. So I want you to follow first to see how we can replace a missing value. I think you know it. And then after, I will export the data so that I can send you clean data set to be able to be on the same page. Because when we start inferential statistics and yet we are not on the same page, it is going to be hard. Because on inferential statistics, sometimes when you have a missing value in a data, you are going to suffer some time. If we say that categorical variables, we normally knows, yesterday Dr. Rema said, for us to tell Ara that this is categorical, we need to convert it as fact. I think you know it. And you are going to see the importance of those kind of things once we start inferential statistics. That's why I said we are going to replace the missing value for the data set we have, and then I will share to you so that we can import the same data set. Yes. So yesterday we stopped by making visualization of the smoker. So let me add another chunk. The data is called patient. Patient Vito. We have seen how to check the missing value into dataset. We use column sum, and then we use is.na. We paste the name of the dataset. This is how we check the missing value as we have seen it. So once we check a missing value, you can use column sum, is.na, and then you put the name of the dataset we are looking for. You see on the asterisk, we have 59 missing value. Yes? On the asterisk, we have 59. Hold on. If you need to run the entire chunk for you to have the updated dataset, can you come on this? Please. Can you come on this? And then you run. Are we on the same page? No. Why? Okay. What happened? Open the previous one. If you run the entire
Yes.
Okay, for us both, we have the data set. Then we are going to replace the missing value. On the asterisk, we have 59 missing value. And on recovery, we have 29. I think we have two variables that has a missing.
Even on age.
Age. On age, we have a missing. Okay.
First line.
Oh, sorry. Recovery day
Age.
and age. So, yes, let's replace those missing value. So the way to replace those missing value, we have seen that because it is on patient V2, we write the name of dataset. We use sign dollar to reference the variable that we are looking for. We are looking for age. Then we put the square parentheses. We type this again. We copy this and we paste it. We can say is dot .na, is dot .na, and inside there paste what you started with. From there, we said, go on the dataset called patient v2, look for the variable called age, and inside there, look for where we have missing value, as we said is .na, and from there, replace with is going to be equalized with, can we say mean? We're going to replace with a mean, just for the sake of running. And you know that you can replace with median when you check the outliers. Mean, this one, comma, na dot remove equal true. This one. From there, the missing is going to be replaced by mean.
So we still have the negative values also in age.
On edge. Okay. For me, I don't. Let me look. Okay. I thought yesterday we removed those kinds of things. Let us check. Can we replace these negative numbers with int? We have seen how we can do it by using gsub. Which package I'm going to run? We still have a negative there. So the way to handle it, this is also the edge. I thought we replace it. Can we replace with this negative number by the empty space so that we can see? This is going to be V2, this one. We type patient. We reference age. Is it the Grims? No. G. This one. N. We converted the entire thing as square. So I can also add can we add it as here? Yeah, this is I'm going to do the absolute value for us to simplify the work of age. You see, when we do the absolute value, there is no negative values that we are going to have there. So this is the simple way we can do this kind of thing. And from there, can equalize it with absolute. Then we paste this for us to be able to have the correct. Yes. So we have seen on the edge, there is some values that has negative numbers, and we can't have the negative edge. We decide to say, let's have it as absolute values. Instead of having negative 67, we can do the absolute, and entire values is going to have positive value. So to do it, it's like write up ABC. That means it is absolute value, and then you put the name of dataset, you reference it by the variable you need to put it into absolute value. So once we check again on this, I think we are going to have only positive values there. So you see it is now correct. Okay. It is correct now. We don't have negative. And you can also, you see we have 31.00 can we have only without the decimals? Because on edge we don't have the decimal numbers. You can't have the 31.0. Yes. Oh, was having a concern that on edge there is some edge that has negative numbers. Yeah, that's what we are trying to correct. Yeah, it must be numeric numbers. But before we change it into absolute, was having some edges that has negative numbers. And then we said in real life, we can't have negative edge. Instead of having those negative edge, we decide to say to the entire values in an edge, let's have it as absolute number for us to anomize those kind of issue. But in a data set we have, there was some edges which is a negative. That's why we said let's have absolute numbers there. So once we do the absolute, you see that we have 31.00 something. Normally in real life, you can't have 31.0 something. It's better to have 31 edge. That is what it can make a sense. What can we do to have integers? Real value. So for us to have it, you can come here after changing into absolute number, you can add the integer. You can add integer. Int. You can have int. Integer. This one. This formula of integer.
Integer is a package.
Integer, it's like the, how can we say the integer? It's a formula, not package. Not package. It's a formula, not package, but helping us to have it into counting numbers. That's what we call the integers. The counting numbers, it's what we call the integers. Yeah. So from there, we can come and then we say integers into this. So once I run this again and I select this, okay. It must have this. As dot integer, sorry. As dot integer, this one. You see now age, it is correct. You can have 31, 46, 47, something like that. So you add as dot integer into the absolute value of those things. And I add the comment. Yes. No. If you say as dot numerical number can have the decimals. But if you say as dot integers, it's a numbers that cannot have the decimals there. It is counting numbers. You can't say if you are counting people, you can't say 1.2 people, something like that. That is the integer. But in a numbers, you can say 1.5 kilogram, whatever. Normally in real life, the numeric, it's what we call continuous numerical data. And when we say we need to have it as an integer, it's what we call discrete numerical data. Those are the numbers we get through counting. It's what we call the integers. But the numbers we get through calculations, that's what we can call now numerical numbers. From there we have a double, whatever, decimals. I think you understand the difference. Yeah. Integers, it's what we use in counting. And age also, it can be numeric. Sometimes you can say I have 31 and 6 months, for example. From there, that's where we can have a decimals. But in real life, if they ask you the how old are you, you can't say I have 31 and the 2.5, for example. But I thought in medicine you can have ages in a decimal. Doctor, can we have ages and a decimal in a medicine?
You can say that.
Yeah.
You have 1 year and 6 months.
Yeah, that's what I was said. But for us, let's have it as not in integer. Yeah. So from there, let's now
I
replace.
understand integer means what in mathematics.
Yeah. Yeah, countable numbers. Yeah, that is a countable number. So then we have heard about how we can change it into positive number by adding absolute. And now from there, we converted into integers. So we are going to replace those missing value we have there. So to replace those missing, yes?
Someone with 0 age.
Yeah, it can be possible. If you have 6 months. If you have a 6 month, what happened?
Half a year.
Can we say 0.5?
No.
That's why. If you don't have age, it is 0. Yeah. If you are counting 8 years and you have 9 months, 11 months, you can have a 0. So then let's replace the missing value. We have seen how we can replace the missing value. You type this and you add the square bracket is dot NA. I'm going to,
You forget to continue with the comments.
okay. We are trying to make positive values. And then after, as countable number. Is it clear? We are trying to make positive value and then harmonize it as in integers. Integers. If we say integers in a bracket, it is countable number. Then from here, we can replace missing value with a mean. We copy this, NA dot remove. Don't worry, I'm going to send the clean data set. So far, we managed to remove this. Let's look for other issue. Where do we have another issue of missing? Are we on the same page? Okay. Why? Okay. So on site historic, that's where we have a missing, and also on the recovery day, that's where we have a missing value. All those are numerical numbers. That's why I'm replacing it with a mean, and even you can replacing it with a mod. Sorry, median. But when it is categorical, we have seen that you can replace it with a mod, highest frequency. And you know how to calculate the frequency. By using a tab, you specify the variable, you get the frequency. From there, instead of saying this, you will come and put in a quotation, you write that category that has higher frequency, and you are done. So let's proceed to the historic. Can also copy this, then paste it here. Change it by putting historic. this one. From there, I can copy this. Let me also do on the recovery days to run it. Once I'm done. So once I run, I'm very sure that there is no missing value we have again. So you see, on the asterisk, you have 59. That's where it is remaining. I can come and copy this code again. Diastolic. Diastolic. It is diastolic. That's where we have a missing value. Yeah, diastolic. On diastolic, for me, I have done with it. Maybe for you, you can check. If I come and check again, you see, data set. And the way we handle it, it is the same. If you need to replace it by median, you can come and then write median here. It's fine. So are we good now? Bring back to the code. Okay. So from here, we are going to see after done with the cleaning. There is a friend who said yesterday, maybe to do the data cleaning in R, it's simple. But for me, I'm familiar with Excel for doing further analysis. Can we export the cleaned data into Excel and then we proceed with analysis? So we are going to see how you can export the cleaned data into Excel and then you continue with doing some analysis. Sorry. You can't see it? Okay. Question is to check if there is still missing. You can use you. So what we use columns to check the issue. When it is okay. Change from this is up zero. This one it is what it can to go back to the table. If you try to see against what you say, you take questions. Can we see? If you wish, you can say and start thinking how we can assume this way. That's where we can check if there is. But if we do column sum, you get zero, means that there is no missing price there. Okay, so let's export the result in Excel so that I can share to you the clean the data. So if we are going to export the result in Excel, what we do, I think, is this here. We exporting the clean the data into Excel. There is also what we call, there is a library called Write Excel. Please, can we follow so that we can move together? Exporting. To export data in Excel, we use a library called Write Excel. If you don't have it, for me, I have it, you have to install it. It's a package, not library. Install packages, put the square bracket. It is called write Excel.
This is a package.
Yeah, it's a package. Write Excel. How can we write it this way? This way, I think. Yeah. Write Excel. It is a package that helping us to export the data in Excel. Even the analysis, you can do summary statistic, frequency table, and you wish to export it into Excel for you to document it, maybe. And then you can use this package of Write Excel. Yeah, you store it, but we are getting an error. Which error? Not found. Put in a quotation. When you're installing something, you put in double quotation. Yeah. Mm-hmm.
Why is this? Look at the story.
Okay. You successfully launched.
Yes, yeah. See this.
It's fine. Warning, there is no problem. Sometimes they used to give you the warning. Warning, there is no error. So then from there you can make it as a comment. If you install the packages in error, there is no other way to install it again, unless if you want to update it. But if you install it, there is no way to do it every day. So for me, I have it. Let's have it as a comment. Once you are done, make it as a comment. And then you call it as library. We have seen it's a code that is helping us to code the packages to be in use. Write Excel, it is going to come. You see, once you write Excel, you call it, then we are going to export patient V2. To export, you write underscore Excel. This one, XLSX. You see?
Right, underscore.
Yes. You see this one? Write Excel. For you, it doesn't work. Why? You already installed it. You installed it. You have to work. Write underscore. Put the name of the data you want to export. Yes?
We can make a dollar sign.
No, put the name of data set. Like we have a V2, patient V2. That is the name of data set. V2 we are going to export. Yes. V2, you put a comma, you write file, equal, sorry. You put the name of the data, patient V2. You look for the folder, the direction, like the path of the folder where you are going to export the findings. For example, for me, I want to export, I come on folder, I want to export my findings on maybe on desktop. Let's see on download, for example, on the folder called Data Plus. I come here on Data Plus. Can I put on folder called data? I come here to copy the path of the folder where the current data is going to be stored. I copy this path. Yeah, that's path. For you, you can go on your laptop where the current data is going to be saved. Yes.
Saying that since they open a project,
Mhm.
they already have the directive.
Okay.
If they want, they can save on.
Mhm. Okay. Okay. So you can come and then you put the quotation, you paste that path. From there, the path is going to come that has slash like this one. You see, you have to change the slash. This one, you have to change the slash into this direction.
What do you call that direction?
You say
What do you call that direction?
forward. Is it forward or backward? This is a forward. You put it in forward. Mhm. And then you add one. Once you are done with this, I changed all the paths that I copied into forward slash. Once you are done, add one,
Add one.
add another forward slash. You see? Then you put the name of that data you're going to export. You need to put the name of that cleaned data. Maybe we can say cleaned data, for example. And I add the extension dot, and then I add the extension of the Excel.
Dot
XLS. It's this one.
X and SX.
If you are done, let me know. Or the simplest way you can use, because sometimes you may be hard about copying the path, the directory, something like that. You can come and check for the directory, the folder that you are currently working on. To check the folder of your currently working on, you can see get directory, get WD.
Where?
Yes. You see, if we use code get WD, we are checking.
We enter now.
Yes. If we are using a code called get WD, we are checking the current directory.
Yes.
You see where I am. You see?
Nothing is coming. Get away, there's nothing is coming.
Okay. Go on the folder where you put. See the data is coming. Nothing is going to come. If you get WD, select this code file.
Which one?
Get WB.
Mm.
Select it. Select it.
Everything.
Only that and that. Control E. This is where you are. And you can run the entire code. You go there to check the clean data.
Where do you run the entire code? No,
And select it. That's one. That's what I mean. You can come and click on this.
Hmm.
This. And this. Yeah. For me, yes. For me, I'm done, and I have to run. Once I run, the data, I exported the data as cleaning the data. So when I go to the other programming folder, I'm going to see that data I exported. You see, when I come on data, I'm going to see the clean the data I exported. Let me know if I was managed to do this. So this is the data we exported as well. You say? For you, you found it. That is good.
So is that data you can start manipulating on it, or it's a clean data?
This is a clean data. So I was saying, once you are done with a cleaning, maybe you have done whatever you want. Even for the summary statistics, you can define the variables and then you export it in Excel. The Excel is going to accept it. Yes.
If you want to change the data language, so my data was collected in French.
Yes.
So I want to
Change it in English.
change it in English.
Okay.
How do I proceed?
So, like, there is a way when you are doing data correction, it comes on who designed the questionnaire. Because, for example, when you use a COBOL to correct the data, there is a multiple way you can put more than one language, so that when you get the data, you can translate it automatically without doing. In a cleaning, we clean what we have. We can't change the name, like the language is something like that. There is no way to code translating an English unless you do it yourself. But when you are designing a questionnaire, there is a way you design so that, let's say, for example, you design the questionnaire that is going to work in Congo, Uganda, Rwanda, whatever. You can put the questionnaire in Kinyarwanda, in English, in French, in Swahili, whatever language you want. So that once you get the data, you will translate it. You will choose the language. That is the simplest way. But when you have data like this as a final Excel sheet, other way is to change it in your own. Like change it one by one. Or even you can use an AI to make it.
When I would like to rename variable,
Mhm. You want to rename the variables maybe into English.
not
In French?
to clear word, like to name it in clear word or acceptable word in academic
Okay,
way.
okay. Let me
When I'm conceiving, when I have a survey,
yes.
I have survey to going to the participants. They are not scientifics. They are not scientifics.
Mm-hmm.
So when I would like to analyze my data and then to, let's say,
You want to change it into a scientific way so that it's.
scientific way,
Mm-hmm.
because
Maybe
when I will be at discussion section,
Mm-hmm.
so I'd like to compare with other articles.
Mm-hmm. So the best way you can use, because when you are doing the research like that, so you have the objectives. From there, on the objectives, that's where you get an idea of designing a questionnaire. The questions that are going to help you to answer the questions you have. So there is no way to make, like, to say that you're going to make it a scientific. For you, you design the questions that is tackling the issue you have. Then from there, once you get the data from the participant, because most of the time the participant, they don't know those scientific something you mentioned. They don't know it. What you do, you design the questions that they are capable to answer you. Yes. Once, yes, yeah. Once they answer, yeah, yes.
But I would like to put it on academic
Okay.
way. So
In academic way, that is what we are doing here. Like if we say mean, mode, something like that, those are the academics that we are saying. It is going to come in real life when you are interpreting. If we say a mean, mode, median, those are academic terms. But when we are communicating the findings, you can't say we have seen the mean of this. You try to relate it into real life. And yet we said we are going to run the inferential analysis. Most of the time, what we are doing here, we can't say it is 100% scientific communicable language. But when it comes to the inferential analysis, like regression and model, whatever, that is mostly the scientific papers there rely on the inferential analysis. But there is no other way to correct the questionnaires into scientific way. To rename.
Like sometimes we even find the question, even the variables are not named well. They have like wrong names, or they have, you just have to change the variable name. Like the column names, I think, and turn them into your scientific or your way you want it. And sometimes they be scientific and you want to turn it back to not scientific. You just name your variables. In
So
case
like maybe let's say we have gender here, but when you go to the field, you can't say gender.
Yeah.
You say what is your gender?
that's your
What is your gender?
what's your sex?
Yeah, sorry, what is your sex? People they say male, female, prefer not to say whatever. That's what they will tell you. And for us, when we are doing,
You can have other conditions that we can't
Mhm,
we can tell what is your sex
mhm,
because it is pro
uh-huh,
it's a kind of culture
okay,
of participants.
yes,
So you have to choose another way, another words that is which is accepted culturally, culturally,
Yeah.
in the participant understanding.
mhm.
So when you come to analyze, you have to change it.
You rename it actually. Yeah,
I
that
like to-
I thought that we have seen about how you can rename the variables. We didn't.
Yeah.
We didn't do it.
simply,
Okay. I think last session we did it, but we can repeat so that you can be sure. So so to rename it, actually you type rename, only rename. You type rename, yes. You type rename. We are renaming the variables. We have asked the participant what is your age, what is your gender, what is your location, but we need to simplify it as a location instead of those longevity. So you type rename, put the name of the data set. If I say the name of data set, let's say like patient V2 as an example, and you put comma, we have seen that once you put the name of the data set, you put the new name. New name you want to put on that variable. Let's say gender. Can we have it as a sex? And as an example, we have a gender there as a variable, but we need to call it as a sex. We type sex and then we put equal to gender. I can type patient. I reference the variable called gender. this one, then I iterate. You see, that is the only thing you can do.
Operate it in front. Renaming. No, I mean the comment.
Okay, I'm going to do it. So yeah, I can do this one. I can do this for me to have it. Renaming. Renaming the variable names. So once I run this, you see, when I check again the names of data, you see, when I check the name of the data set, I will also have, you see, gender has not changed. Why?
Have you run it?
I didn't run actually where the line is.
Stop.
Where? Ah, this one.
No, but
But maybe it's 60 to 20.
renaming also, you have to include that renaming.
Unexpected name. Let me put in the let's add another chunk for us to simplify. Rename, it is not working. Let me library first. Tidyverse.
أنا واقف زي كمان طلعت بس زي في الفلوس بتاعي.
You say? Deep right. Ikibazo biteye. The column name doesn't exist. Okay. We put this one. Sorry, I deleted the name of the dataset. Using a sign. Yeah, you see now it is working.
What was the issue?
The issue was I referenced the variable, but I didn't. I deleted it actually, but I didn't see it. This one.
So the results.
The result is a sex. It was having the gender, but now we have it as a sex. This one. And you can do it to the entire variables once you wish to do it. So Babu, sharing ino data ngo hano. Check on email. Yeah. So we are going to use that data set Fabrice is going to share so that we can proceed. I think you have seen how you can export the findings into Excel. And to rename, that is also how you can do it. It is also the same case the way we use mutate, transmutate, whatever. Like you put the functions, name of dataset, new name, equalizing with existing name. That's what you can do only.
To install the package first.
Yeah, you have to restart the package first, called deep ROI. This one. But if you have tidyverse, I think there is no way to have it as this because in tidyverse also can perform what this package can do. This one. So after exporting the findings into Excel, we are going to, you have seen how we can replace the missing value. So we are going to start on categorical variables. How can we get percentages instead of having only the frequent? Because yesterday we have seen how we can get the frequent, but we didn't see how you can get the percentages. But most of the time when we are reporting, you can't say that the male was 500, female was 600, something like that. You can say it, but what most people need, they need to hear the percentages, especially when we are analyzing the surveys data. We use percentages when we are reporting the findings. So yesterday, Dr. Rema said, when we need to tell Ara that this is categorical variables, we need to change it first as fact. Is there any concern? Brian, is there any concern for online people?
The screen.
Screen. You didn't see the screen?
Yes, we cannot see the screen.
Okay. Ah. You see it now?
Yes, we can see it now.
Okay. Where we are. So we have seen how we can convert the numerical categorical numbers into fact. That is the simplest way to tell the other that this is categorical numbers that we are going to use. So how can we do it? Okay. We have seen, you can say structure. When you do the structure, and then you put the name of the data, patient. We are trying to see the structure of the data set we have. You see, we have only sex as factor, but when we have the outcome, it is a character. But when you need to do, you say, we use structure to see the structure of the data set. Yes? And for us to be able to make sure that we can perform anything related to categorical analysis in R, the categorical numbers, the categorical data we have here, by default, it appears as character. But we need to force it as fact. That's what we are going to do. So to force it as fact, you say, you put the name of the data set, so patient V2, you can import that in the data so that we can move together. You type the name of data set, you reference it, because I have 6, and I want to make sure that in a 6, yes, in a 6, obvious, in a 6, we have it as a fact.
As
Fact. That is how, if we have it as a fact, that's where R will recognize it as categorical. Yeah. Then we have only 6 as fact variables in R currently, but we need to tell R that even smoker, it is also categorical, even outcome, it is also categorical, something like that, and even weight, is it categorical? It should, or it should be numeric. We have to change it. We have to see the reason why we have it as a character, and yet it should be numeric. We need to clean, okay. Insurance provider, attendance doctor, diagnosis like malaria, tuberculosis, we have to have it as a fact instead of having as a character. So to do it, you reference by using sign dollar. Let's start on smoker, and then you say equal as dot fact, only this one, as dot fact. You repeat the same song as you did here. This one. This is going to change it into fact. Yes? So you do it to the other variables, like we have done with the smoker. You can also do the outcome, patient, V2, outcome equal as dot fact. You can also do on diagnosis, patient V2. This one. Is there any variable we can have it as a fact? Smoker diagnosis. This is enough. Yeah, there is no insurance provider. There is no way to have the fact of insurance provider. So once you check the structure again, see if you check structure again, you see that smoker now has come fact, and also outcome has come fact, and then also weight, we are going to change it as a numeric because we should have it as a numeric. Weight cannot be categorical. Diagnosis, you see, we have a levels there. That is what we normally want to do, actually. Yes. So, okay. There is a concern here. But why are we doing this? Like, why we say as dot factor? As Dr. Rema said yesterday, when you import the data, which is categorical, so it's a word. The question is you ask it, and then they are going to respond you into truth. Okay, sorry. Allow me to show you this. When you import, yes, screen. Is it not visible?
Maybe when the screen
When the project. Mhm. Okay. Now it's clear. So by default, R say consider is a categorical, but we need to tell R that this is categorical. By forcing it, recognize it as a fact. It is the same case as we said when it comes to the real life. When we say the variable, just understand that it is question is we answer to we ask to get the response. That's what we call variables in a real life. But when it comes to the other programming, when we say the variables, you mean that it's assignable something in other programming or even in a programming language. And when it comes to the real life, what we call categorical, it's categorical variables. When it comes to the other programming, we recognize it as fact. That's why we need to force the other to say that where we have a cracked, consider it as a categorical. And other, when it recognizing the categorical, it recognizes it as a fact. That's what we are doing. And it will have an impact when you are doing inferential analysis. So let's proceed now. How can we get the percentage? So to get the percentage, use proportion. We calculate the percentage for categorical variable. We can't calculate the percentage for numerical variable. I think we are on the same page on this. So we, yes? You say?
Yeah,
The code here.
yes.
Okay. You have an issue. You need to see the code. You type the data set, you reference the variable, and then say as.fact. So can we continue?
Yeah.
So when you need to see the percentage, you can use proportion table. If you do proportion table, you type the name of the data set, you select the variables you're looking for. Let's say, for example, we are looking for sex. So then once we are looking for sex, we have to run. You say? Come in. Mhm. Frequency and percentage. First, the frequency should be this. We are using V2. You see, You have only this.
What's that? That's the result.
Those are, we still have a missing value into gender. So into sex. That is the result. It means that there is a 61 missing value. We have 255 female, and we have 295 male. So how can we turn it into a percentage? So the way to turn it into percentage, we do proportion table. You copy this at the same, this one, and then you come up with multiply by 100. After doing this, you multiply by 100. So once you do this, not meaningful for fact. This one. Now. Percentage.
Then table for the sample sheet. Table first. Right. Yeah, then do work. And smoke, not smoke.
Smoker. This one. And we can add, we can reduce the decimals.
Is that percentage something? What is it?
Can we multiply? We can multiply by 100 to make it easy. If we multiply by 100, we can have 10%. 10
10% is for one.
missing value
For the one,
as a who don't smoker.
it's only those are smokers.
47 are the smokers we have.
If you want to trim those percentage, those decimal points, can you?
We can reduce the decimal.
No,
When you
trim.
okay, if you want to trim, you can add the code round. You can round up. You add round, then you come here, put a comma. Maybe can we round in two decimal place?
Oh, 0 decimal.
You can say 0 decimal. It's fine.
Possible.
It's possible. If you do round in a 0 decimal, you are going to see only this one. Yes, I was right, just like checking, but there is no way you can remove it. Mhm. From here, we still have a missing value, but we can replace that missing value by what? We can replace missing value by yes, because we have seen for the categorical data, when we are replacing a missing value, when it is below 25%, we can replace it by mod. The mod here, it's those who smoker, who said yes, because that's where we have higher number. We can replace those missing value. Instead of have 10, we can allocate it into smokers. Can we do it? Okay. To replace those missing, can say patient V2. Then we say smoker. Square bracket is dot n, this one. Then equal. We put a quotation and then we copy the name of yes. We put it here. You see. Once I run, I replace the missing value with this one. So once I come on this formula here, I put it is only that.
No change.
Let me run this first. Let me try it first. Let's see on smoker, the way smoker it is. We have yes and no there, but yet we have it as a fact. Can we check for the levels for us to see? Should have this. When I do this, I'm expecting to see one. False. This is not fact. It means that it is correct. Let's check if we still have that missing. Don't have it on 6. Mhm. So on 6, we don't have a missing value there.
I think when there's a result for
There is a, you know why? Maybe on the data set we have, there is no missing there, but there is a space there.
10, just that 10.
There is a, you see, when we are looking for the missing value, we see that there is no missing value we have in a data set. And yet, when we run this, we see that there is a missing. What happened? It means that in our data set, not the missing value we have there, but it recognizes space, not a missing value. Let's access first where we have those input space to see. Let us see. Do we have this? Where we have those space? There is nowhere we have a space. And we replace it by let's see on 6. In case where we have Need to see. Don't see the space. That's where we have a space. You see, we have a space instead of having a missing value. That's why when we are replacing a missing value, we see that there is no missing value, but inside there is a space. So we are going to take this space and replace it by a missing value. We replace it by a mode. As those who said yes, we are going to treat it like that. How can we do it? You can say space equal. This is simple way. So then I can say take a space and then equalize it with a yes inside there. This one. Is this going to work? Once I check this again, I think it is still now. We can say
It is increasing.
it is increasing.
Can you see now?
Oh yeah.
It was then at 63.
It was a percentage, not a number.
Yes.
The reason why you have a 10 was a percentage, not a numbers. So we are going to take patient V2 in 6 where it is equal to the space. Yes. Let's have it as in a square. You see, 60 something. Okay, that's where we have this. And we can also equalize with the yes. We see. So once we run, you're going to see if it has changed. No. What was that? Let's add in. And read this one. We have null now. Okay. Oh. We replace it the entire observation. Let's do replace. So that we can see. Okay. Let's run the entire code to see. Mhm. Okay. There's no patient here. Patient V2. Yeah, that is correct. Come. Okay. Do this. We said patient. That was a smoker. Patient where we have a missing value. We are going to replace with from there where we have this. Can say inside. This one. Where we have a space like this, we're going to replace it to a double equal, not single equal. This one. So this, yeah, we are going to look for the smoker where we have space, and then we equalize it by yes. This one. This one. Let me read this one. Okay, now it is fine. Do this. So we are going to look for the patient smoker where we have a space, and then we equalize it with yes. For us to simplify those issues of having 10 something, you see. Here we are having this one. We are looking on the table, and then we see that we have almost this, but we need to change it. Yeah, do this. And we change this again. You see? Yeah. We are looking on the data where we have a smoker, which is equal to the space, and then we replace it by yes. Because when you look at the Excel we exported, this is not the empty, this is not empty as we say this one, like, it's open, then we see as in Excel. We can even view. When we view the data, patient V2. So when you view the data and you look at the smoker, you will see sometimes there is the missing. When you look at there is where we don't have the information. And yet, this is not recognized it as a missing, it is a space. So that's why we need to remove those spaces into that. We decide to say where we have this space, right here, can we replace it by yes for us to simplify the work? That's what we do. Because this is not a missing value, it's an empty character. They put maybe the space. Suppose during the correction of the data, instead of writing the information, they put the space and then they continue. That's why when we are checking a missing value, we don't see nothing. That's what we did here to replace those missing with this one. This one, that's what we call a missing empty character as this. Once you check on, if we check on smoker, we're not going to see it again. This one. Okay. You can't view the single variable. This, yeah. Where we have this empty, those are the empty spaces we have there. Those empty spaces, we replace it by this one. Do it and then we'll see. So we are going to see how we can also do the tabulation of two variables. Sorry. I deleted. Let's also do it on the sex as well. This is for the patient. Let's do it for this one. This is also gender. From there. Sorry. The empty space with the highest frequency, not more, not highest frequency. Do it on the gender also, it is going to work, but also in the same case on the smokers. Is this code working? Mainly for unnecessary space here. Patient gender, train patient gender, it is equal to male. So let's see how we can do the categorization of two variables.
Train function in one
It is not working.
train MW.
This one, it is not working for you. Run the package called dpryy first, and then it is going to work. Use trim S, something like that. This one, it is going to work. For me, I write trims, this one. Yeah. Trim WS, not trims. Yeah, it is working.
With the results.
You say? Trinity help us to remove the blank spaces there. Yeah. When we look at gender, I decided to cross. What happened? Table. So I run the library. When we see the table, we have a 0. Nothing there. We have a 0, which means the males are this one. Female are 255, males are 257, and yet we was having 296. So that's why we replaced those missing with female. And for the same time, you can also do it for the smokers. It is going to work. When you use this function called trims, let me comment. In removing it will help us to remove unnecessary spaces in our values. So you can also do frequency of 2 variables. Like we can say how many gender who take smoke, how many gender who do not take smoke. Yes. When the highest mode are 2, maybe it is equal. For example, you choose 1. Let's say gender and female are equal, 500, 500. Both are maybe the modern. Choose 1. Because there is no other way, maybe to say we are going to find the average, which is not possible. Choose 1 you wish. Sometimes it will depend on the purpose of the survey you are doing. If you need to see mostly like the university student, and yet you see that the university student and the education level are the same, you can go with the university student. You judge yourself based on the result you want to provide. And from here, if you need to see frequency of 2 variables, you can say, let's say we need to see gender by smokers, for example. If you want to see it by smokers, gender by smokers, this one. If you want to see the gender by smokers, for example, you can also see it. And you see 0. Where do we have 0? Why do we have 0 here? So okay, the missing value now was replaced by 0. Instead, missing value was replaced by 0 instead of having, can we say, instead of having trims in this way, you can also have 0 as here. And then we replace this by, this is going to work. So yes, once this is going to work, once I come here, why this is not working? Still, okay. We see on this one. Among the female who take smoke is 114. This is correct. Among the female who take smoke, it is 114, and male who take smoke is 178. And then from here, you can see for those who don't take anything, it is 112, and here it is 143. But also you can add
Zero,
hope.
zero represents what? Please.
0 is representing, so
And then that number is also representing, but yeah. There's
this
female,
one
male,
we
and
have
then-
0.
And then that, there are two things. There is yes, no, and then the other one is what?
Let me replace this 0 by female for us to see. Can we remove? Okay. Replace. So let's replace. Can we replace this? Could not find the function called replace. Let's see where the function replace belongs. Patient gender in a list. Gender is equal to the empty space. We have there 0, and then we can replace it by female, male. Sorry, this one. I think this is going to work. Can we take a decision to take a 0 and replace it by male?
But if we remain with them
Remain with event.
empty,
How?
It appears like a table of the factor.
It
If
is
you check the levels of the factor for gender, we will see this like empty.
null value.
That's why they are still
can we let them stay there?
They transferred the counting to the names, but the category, the factor remains.
The factor remain.
Yes, so we can draw that just factor.
Okay, can we? You mean I can go with the factor variables at those
If
parts?
we check the factors for the gender, we see there are three levels.
Let's see. For gender. As dot factor. And then let's see this. We have female, empty space. The input space has 3. You see, we have a 3. Okay, so can we say now, once we change it as a fact, can we say here, can we put the 3? Where we come and we see, can we come here? And then we say, because we have seen that there are 3 there, can we say that where we have the 3, because these 3 represent zeros, can we take these 3 and then we replace by female to see if they can work? So from there, it's working. Still now, it is not changing. Okay, can we ask? Let me ask GPT to see. Let me ask. How can we remove what happened? Not enough space. Okay. Let me stop sharing so that let's remove.
Can we use the drop level as action? Try and use the entity.
Drop levels.
Yes.
Okay. Let's see. Why it is not working for my end? We can use this one. Replace patient, which is equal to this.
what happened to
For your end, can you try this and then to see if this can work for your end? For me, it is not working. This one. Patient gender, drop levels as dot fact, something like that. To see if they can work for your end.
That's it.
Yes,
10 minutes.
straight for 10 minutes. Okay. Let's take 5 minutes. For others, it is working. Okay. For me, I don't know the reason why it is not working. This one, drop levels as dot fact, it is the same, but I don't know the reason why. Maybe it is because of my R version, maybe. I have the version maybe which is different from what you have. But if I run, I'm expecting to get the same result as you see. But you see, for me, it is not working. But if for you it is working, we can proceed. At least we can see. Let me. We can proceed. Let's do this one and then we take 5 minutes for break. We have seen how we can also tabulate more than 2 variables. Like we have a gender and the smokers. You can see how many people who smoke that are a male or female. So you can do this table and then you put a comma, you add another variable you want to look for, especially when it is categorical. You can do this. You look for gender and also at the same time for smoker. From there, you can see maybe for smoker, this one. When you tap this, you see, still for me it is not working. For you, you change it. These numbers are not going to see it here. People online, you can try this one to drop those missing value, those empty numbers we have here. And I think for you it is going to work. You will not see this that I'm seeing. You see, when you look at this data we have, like the female who takes smoker are 114. Those who don't take smoker are 112. But from here, you can also wish to put it into percentage. So when you need to put it into percentage, you need to add prop dot table, this one, proportion dot table, and then you cross a bracket, you multiply by 100 for you to simplify it. If you multiply by 100, you see that we have 0. Don't look at this because for me, I have an issue on my data. But for you, you will have something like that. Yes. And from here, you can also do round up. Yes.
Can't you add percentage as a symbol?
As a symbol. Okay. Let's round first and then we add on. Okay. You can do round. So you can also put this one and then you can do this one. If you do round, you will see that instead of having decimals, I round it for 0 decimal place. Start first by this one. Start first by this one to see only frequency. When you want to see only frequency, you start by this one. And when you need to add a percentage, add prop to table. When you want to multiply by 100, multiply by 100, and then you can round it into 0 decimal place. or even I can say two decimal. Most of the time we prefer to say two decimal place. If I put two, we are going to see two decimal place. So I didn't run the entire code. Two decimal place, like this one, 0.6.60. That is the simple way, like the presentable numbers.
Then for the symbol, like for symbol.
For the symbol, like the percentage, we can also do print. We can also do print and then say this comma, and then we can do this one. Can we add the percentage? So this one. So here. So if I do this, let us see. Introduce cohesion. Let's see. I don't know exactly how this can work. Let me search.
And the paste is
I can use paste. This can also be the simple way. Instead of having as percentage like this, we can use, if you say margin equal to something like that, I guess we are going to have it there. Let's see. Oh, still nothing.
paste.
If I use paste, paste 0, this is going to work. No need to add this. This one. Yeah, this is going to work like this one. But the problem is, you see, we can't see based on the categorization. We can't see it. Let me remove this one and then we still now. You have to define this first. So this is a correct. We have to define it first, like this one, the way we did it. Let me run this. When I do this, let us see. And when I run table to see if we are going, here it is working. So what we add on what we did first, we have to define the table, to define the variable of that summary statistics. Like we did round off proportion to table, then we multiply by 100, we round with a two decimal place, we add paste 0, something we generated as this, And then after we do tab, when we do tab, we are going to see the result. Like those who said no, those who said yes, female and male. This one. But for you, this is not going to be visible. Yeah, if the code are correct. Because for me, I dropped the rebels, but I didn't see it is not working to my end. But for you, I think this is not going to come. Yes? Or you are seeing the same thing I see? Are you seeing the same thing I have? Okay. Take a break. Let's take 5 minutes. We'll come at 12. See, almost 6. Once I check, we are going to see that result as well. This one. It. This one. Right, Excel. So once you run, we are going to see the result there. So then I check. First, okay. This one we need to also first to change it as data frame. That's why. Data.frame. We need to tell R that this is the data frame. That's why it is not working. We need to say it should be the data frame first. Once we have it as data frame, it is going to work. You see now it is working. So even though we have it as a summary tables like this one, but we need to convert it as data frame. So once we convert it as data frame, when I come on ARA, and then I check on the folder where I send my data. Data plus medication. This one. You see data plus medication data, something like that. When I open this, I'm going to see that data that I exported on Excel. That's where you can do the analysis, but also at the same time, you can export it in Excel, maybe for making some tables. They will ask you to do some tables when you are doing analysis. That's how you can export that result in Excel. So, other thing we can do, once you are done with this, you have to change it into a data frame before you export it in Excel. Other thing we can do, we have seen how you can do the frequency tables for more than 2 variables. From there, that's where the inferential statistics start, or on the side of categorical variables. Like for example, we know what we call chi-square. Mostly the inferential statistics, it's come for complementing what summary statistics provide. For example, you may ask yourself that, is there any relationship between gender and smoker? for example, just to confirm. Yet you have seen some percentages that showing that there is some similarities. When you look at this, like this one, when you run this, you see that there is 5% of the female are taking smoke, and 18%, oh, sorry, 18% of female are taking smoke, and 23% of male are taking smoke. But you need to confirm if there is a relationship. That's where the inferential statistic will come, right? To confirm those kind of things, to complement on it. So for us to do the chi-square as a side of inferential statistic, can say the inferential statistic. So when we are doing chi-square, we say chi dot test, because we have done this tabulation. When we are doing chi-square, we always start on tabulation. So when we are, what we will do, we will come and say tab of this, and then we say patient V2. Let's say we need to see if there is a relationship between gender and smoker. So we select gender, then comma, we put patient, and then we select smoker. Smoker. If we select this, and then once we run this, so chi-square, gender and smoker. So once I run this, I'm going to see, you see, this is what I see. We see that the p-value, this is the result of how chi-square should look like. And when we are interpreting the result on chi-square, we normally look on the p-value. And if we see that the p-value, it is less than 0.05, like 5%, we conclude that there is no association between those two categorical variables. But if the p-value is less than 0.05, we will conclude that there is a relationship. But when you look at p-value, we consider them at the comment. Taking decision. If we see %, if we say 5%, it is 0.05. That is 5%. 0.05. Yeah, that is 5%. So for you, we look at the p-value, and if we see that the p-value, it is less than this, it means that there is association between gender and smoking. But we have seen that the p-value, it is higher than 0.05, which means our data showing us that there is no association between gender and smoker. That is the conclusion we can conclude. But from here also we can look for the another association between maybe gender and outcome, for example. To look for the association between gender and outcome, we will do chi.test, and then we look for the patient V2, then we select gender, we add comma, we say patient again, and then we select also outcome. When we look at outcome, we're trying to see if there's a association between this. So what I will do, I have to add tab first. This one. This one. So when I do this, I will also see that p-value, it is also still high. It means that our data showing us there is no association between outcome variable and also gender. So that's how you can do the chi-square, especially when you need to confirm the association between categorical variables. That's what you can do on side of inferential statistics. Number one was the chi-square. Chi-square test. So another we can add on, it's also what we call correlation. Correlation showing us if there is a correlation between numerical variables. Let's say we have age, we have diastatic and cytostatic, something like that, but we need to see if there is a correlation between age and systolic and diastolic. From there, what we will do, or we can't rely on summary statistics only, we can also rely on some inferential statistics, correlation as an example. On correlation analysis, we do correlate, call, stat library. We have to call the library called stat first. We have to call the library called stat. That's where correlation we have. We have to call library called stat. And from there, if I write call, or call.test, we will also have to add the correlation between dependent variable and independent variable as well. So we need to look for age and diastatic and iastatic as an example. We can add also the patient, and then look for age. Then after you can add the patient, and so you can look for maybe cystotic, something like that. So from there, once we run, we are going to see there is also this is the correlation result. So the same thing when we are doing a correlation, when you are looking for the correlation, most of the time we started by looking for the p-value. So the way we interpret the p-value when it comes to the inferential analysis, it is the same. Since we see that the p-value, it is not less than the level of significance, it means that there is no powerful correlation on that variable. So since we see that the p-value, it is higher than 0.05. The correlation are there because when you look at the estimate here, this is a correlation, but it doesn't have high influence. Like for us to confirm if this estimate, the programming give us, we need to first look for the p-value. See, the p-value is higher than 0.05. It means that there is no, even though we have a correlation estimate of negative 0.0 something, there is no correlation there. Yes? And normally knows in statistics, when we have the correlation which is between 0 and 0.2, there is no correlation actually. That's why we have seen that the p-value, it is higher than 0.05. But also you can add more variables. When you need to add more variables, because you can do the correlation matrix or correlation plot, for example. If you need to add more variables, use this side. You come here and add this side. You can use plus something. You can come and then use plus sign, if I'm not mistaken. You can use plus sign to add more. You can also use plus sign, maybe to add more. Diastatic. Can we add? Oh, sorry. Patient. And also we can add diastatic. Since we have diastatic, then we can run to see. You see, I added more variables. So you can continue to add more variables as you wish. You see, you can continue to add those variables as you wish. So what else we can do? We can also use this side to see if we can have correlation matrix. Not this one. Come. From here, you can also plot the correlation as you wish. For example, you can see the coefficient, but let's assume that you need to plot the correlation matrix as a plot. You can do plot I need to run ggplot first. Library called ggplot2. Once we run ggplot2, we can also do this. Then also we can say plot as the next one. Let's see if it can work. We need to see plot. This plot, this one. Unexpected, this one, sorry. Plot.xy graphics, something like that. This one. That's where you will see if there is a correlation, maybe positive or negative correlation. Please wait out. Yeah, this. Let's see. This is also what you can do. And most of the time when you're interpreting the correlation chart like this, we are looking for if there is a relationship between age and historic, and we normally know if we have the graph like this one, it means that there is no correlation because it is on the same, like it has a parallel directions. And when we have a correlation, sometimes we will have a dot in this way, like a dot that is in right direction or left direction. But since we have it as scattered like this, it is forming the parallel visualization, something like that. It is confirming that there is no correlation that we have there. That is the other way you can see the correlation chart without looking for the correlation coefficient. So to look for the correlation coefficient, that is the way we did here. But if you need to see it in terms of visual, like this is a correlation coefficient, you see that even though there is a correlation here, 0.01, it means that 1%, there is a correlation of gender and there is a correlation of age and historic at the level of 1%. Because if you take this and multiply by 100, this one, it is going to be 101%. So even though there is a correlation of 1%. That's why the p-value is higher than 0.05. Yet they are there, but it doesn't have higher influence. That's why we normally look for the correlation when we are doing this kind of thing. So, but also you can plot it. Another inferential statistic we used to have, instead of correlation and chi-square, we can also have, what else we can have? We can also do ANOVA, analysis of variance. Sometimes when we are talking about the analysis of variance, let's say the categorical variables that you need to compare, it has more than two values, two more than categories. Like the chi-square, it applies when we have like a gender and when we have a gender, like a gender, we have two categories inside gender, female and male. And we are comparing the gender and the smoker, where we have on smoker yes and no. But let's assume we have education level and gender. On education level, that's where education level has more than two categories inside there. You can have, for example, you can have PhD, master's, bachelor's, secondary, no education, but you need to see if those education levels has the influence uh, on smoker, for example, or on gender. It means one variable that is there, even though it is categorical, it has more than, there is a variable has more than two categories inside. That's where the analysis of variance will come. You don't understanding? Yes, you don't understand the difference between analysis of variance and the chi-square, or you know it.
Can you give us more explanation how those two
ANOVA.
tests?
Analysis of variance and chi-square. So chi-square, it is showing us the association between two categorical variables that has inside two categories, maximum two categories. If I say two categories, in a gender we have male and female only. But in a case where we have prefer not to say, the chi-square is not going to work. Yes? I don't, maybe I see that you're not interested. Okay. Why are you not following? Okay. From there, when you have the variable like this one, let's look at this. So let's take an example of the data set here for us to see. You see, can you follow to see how this can work? So most of the, when you look at gender, we have only two categories, male and female. And when you look at outcome, we have decreasing, ongoing, and recovery. And sometimes we also have another variables like insurance provider, something like that. And yet you need to know, is there any association between the insurance provider and outcome variable? Because in these two variables, we have inside there is a more than two categories. If I say two categories, it's like you understand what it means. We have a recovery, this is one category. Inside that variable, we have ongoing, the second category, and we have deceased as the third category. On that case, the chi-square will not work. Chi-square, it's work only when we have not more than two categories into that variable we are looking for, like a gender and smoke. It's where we have a male and a female, and yes or no. We need to confirm based on those variables, and yet it has not more than two categories inside there. Only two categories, yeah, are compared on chi-square. But when it comes to the variables has more than two categories there, that's where we will use analysis of variance. Yeah.
That's correct.
Yeah. So then from here, we can also come on ANOVA to see how it is. The way we interpret ANOVA also, it is also the same as we interpret the chi-square. First, we look for the p-value. Once we see that the p-value are not less than zero, are not higher than 0.05, we will confirm that there is association there. So the way ANOVA, it is also work. We say are over ANOVA test. If you type ANOVA, you can also say I want to see the association between outcome, because on outcome, that's where we have seen that there is a more than two categories, and insurance provider, for example. Can we look for the outcome and insurance provider? So that's where once I run, let's run and then we see. Crude not applicable. Yeah, it is a character. We need to change it as a fact. That's where we will see the importance of changing it as a fact. Because it is a character, other tells us that ANOVA can't accept the variable which is character. Even though we are looking for the categorical something, but we should make sure that it is fact. So that's why we need to say as dot fact first. Let's check the outcome. Change it as fact first. Changing as this. And then as dot fact. And then also we can use the insurance provider here to see. So from here, I think now it is going to work. And we look for let's look for this one. As that fact, this one, they can take this one also. No, what? So this, it is changing. When we look for the structure, let's look for the structure first to see. But for you, you have changed it already. On outcome, I didn't change it as cracked, so I have to do this. Do this, paste it here, and then say it equal. And even here, you need to change it in this way. When I see, you see on what? On outcome, it is already fact, and on diagnosis, it is also the fact as well. So then when it comes to the ANOVA, applied to the object factor error during not applicable. What else we can do? Let's use ANOVA equal let's see the code. Where do we have ANOVA? We use this one. Not ANOVA as such. Let's use this. We say we need to see the relationship between this one, outcome, and the insurance provider. We copy this, we paste it here. We remove this one, and even this one. We use this sign. We start on the dependent variable, and also we follow the independent variable. So then after adding this, we come here, then we say data equal, we put the name of the data set where the variable it is located. So from here, we are looking for this one. From here, we are looking for not meaningful factor. Warning message, there is no issue of having a warning message. But from here also we can print the result, and then we see if we can get the result. Only 0 may be mixed with negative. Do we have a problem in?
It's because we are, our variables are both categoricals. For another one was
We are comparing means.
We
Okay.
compare the means across the categories.
Let me add the edge here to see. Edge here. So now it is working. So insurance provider. So for us to see the real result, we can't print like this, but we come and add summary. To see the summary to be interpreted. We add code summary like this one. You see, this is the summary we normally need when we are doing the interpretation. So the insurance provider, it has some square of 19,729. But for us, what we look first, for us to confirm if there is a variation or not, we look for the p-value. So since we see that still the p-value is higher than 0.05, what does it mean? There is a difference there, because normally the ANOVA said there is no difference between those categories among the age. Like when we are doing this, we are assuming that we need to see if the insurance providers, if there is difference between the insurance providers and their ages that they are targeting. So since we are testing it by using ANOVA, we have assumption that is saying there is no difference between insurance providers and the average age they are serving. Since we see that the p-value is less than, it means that there is no variations there. So I think from here, I think for here it is clear. Mhm. You still okay? Can we continue on regression analysis? Okay. So there is a lot of inferential statistics. There is a lot of method you can use. Not only this, but is a many. But I'm trying to say the common one we usually meet with when we are doing analysis. But there is a lot of inferential analysis you can do. So the regression analysis telling us the relationship between, we started on correlation analysis, on saying if there is a relationship between numerical variables. Correlation supports us to see if there is a relationship between numerical variables, only numerical, not mixed, on correlation. And yet we see that, let's assume when we see that there is a correlation, we come on regression to see to what extent. Let's say, for example, we have seen on correlation, there is a correlation between age and diastolic, for example. Maybe there is a positive or negative. From there, regression comes to tell us to what extent does this influence this, only for the numeric.
Is there a relation between those?
Is there a relation? You see it on correlation. If you have a curiosity to see if there is a relation, the correlation comes to tell us if there is a relation or not. Once they confirm that there is a correlation, we come on regression to see in terms of numbers. Yeah, that's why the regression comes, to provide the exact numbers of that correlation. And we will also have to see what we call logistic regression, mainly comes for the chi-square comprehension. Like chi-square, as we said, it is looking for the categorical analysis to see if there is association between categorical analysis only when we need to see how many percentage then does the female influence on taking smoke, for example. We will do what we call logistic regression, not regression analysis. We will see the logistic regression, how it works. So let's look for the regression analysis first. So On regression analysis, of course, we focus on numerical values only. So let's say regression equal, what are we doing? LM regression model. So we write LM, we put the dependent variable. Let's say the dependent variable, it is age. We need to see, we write age, this one, and then we put this. We start by dependent variable. We put this sign, we put the independent variable. We can also start by diastolic. And I add diastolic. To add the diastolic, I can say patient ID, diastolic. Then I delete this one. I can also add other variable because you can have more than one independent variables on regression. That's what we call multiple regression analysis. But when it is one dependent and one independent, it is what we call simple linear regression. We can add another variable by saying patient, just to select it. Can also come on, we put diastolic, we can put diastolic, yes.
I don't understand why you don't put patient next to before system.
No, I'm selecting only the variables. I will add the data, like you see the way we did it here. The way we did it here. You see, we type only the variables, we type age, put this sign, and then we put the independent variables. The reason why I'm using partial, it's like for selecting the interested variables. But I will remove it, I will add it, at the end. You can also add another variable, like more variables. Can we add the recovery day? We can come and then add the recovery day. Even you can also put the treatment cost. Fine. You can put the treatment cost. You can also partial. You can also put the recovery day. Can also put the recovery day. What else we can add? You have put systolic, diastolic, treatment cost, recovery day. What else can we add? Let us see if there is. You can also add which one? Yeah, I think this is enough. Let's keep this one. And after putting the independent variable, we put the comma, we type the name of data, and then we add patient V2 as the source of where variable is coming. Once you're done with this, we only have to run, and then we do summary of the regression. Summary of regression. This is also the summary of regression. You see, this is only the summary of regression we can do. From here, this is our regression model. So that is mostly the scientific analysis. Yes, you have. Yeah. And from here, you can export this summary statistic in Excel. let's say, for example, you need to export it in Excel. So the way to export regression in Excel, you need first to change it into a data frame. Like you can come and say, this is a regression you have already done. You need to try to export it in Excel. You say this data.frame. The code to make it as data frame, you use data.frame and you copy the name. Once you do this, where this cannot be into the data frame. What can be into in data frame? We can look for the coefficient. Can we look for the coefficient? Yeah, we can do coefficient only. Do you understand the coefficient? If we say coefficient, you understand what does it mean? Okay, let me explain. No coefficient, what? Let me have it as a comment here. Then we see. You see, this is a regression. First of all, when you need to do the interpretation on regression analysis, as I said, you always look for the p-value first. Before you do any kind of interpretation on inferential analysis, you always look for the p-value. This is also the p-value, probability value. Since the level of significance, by default, it is 5%. When you come here and you see that the p-value is less than 0.05, you will try to think about that. There is a relationship between those variables that has p-value which is less than 0.05 and the dependent variable. For us, the dependent variable, it is gender. So we need to see if there is a relationship between, is there any influence of systolic, diastolic, treatment cost, recovery day on age? We are trying to see if there is the influence of age on our data we have. So for us to make the interpretation, come on here. So when you look at systolic, the p-value is 0.5, which means when you multiply by 100, this is going to be 57%. It means that the p-value is higher than level of significance. What does it mean? There is no relationship between systolic and age. When you look at the diastolic, still the same. When you look at treatment cost, still the same. When also look at the recovery day, there is no relationship. But let's assume there is something which is less than 0.05. You will come on this estimate to interpret that coefficient as well. So this estimate, it has a value when the p-value is less than 0.05. We are going to take an assumption, like to assume that, let's assume that this recovery date, for example, let's assume that this p-value of recovery date is less than 0.05. It is an assumption, but not true based on the data we have here. So we will come on this estimate. We said for every day increase, for every age increase, for every day increase, for every 1 day increase on recovery, the age will decrease by 0.0 something. That's how we will interpret this result. Okay, let me repeat. You see, we have a negative numbers. And when we are making an interpretation, we are looking for every unity increase on independent variable. To what extent is going to be increased on dependent variable? Yes? When we are doing a regression, we need to see for every unity increase. If I say unity, it can be because we are looking for recovery day. For 1 day increase on recovery, to what extent age is going to be increased or decreased? What happen when the recovery day increase or decrease on age? That's what we need to see. Yes? And let's assume that the p-value was into less than 0.05 and the coefficient is 0.0 something like this, as we have it here. We will interpret the result by saying that for 1 day increase on recovery day, yes? Maybe you don't understand. Okay, let me type something here. So normally when we are doing regression, we need to see, like, we have dependent variable. What does it mean, dependent variable? Effective variable. This is what we call effective variable. The result we see. Yes? And the independent variable, it is also what we call cause variable. Cause of that result we are seeing. So cause, people online are seeing the screen. Okay. Cause variable. And when we are doing regression, it helping us to answer this question. Is there any contribution of those cause variables in the effect on the effective variable? This statement, is it clear? Is helping us to answer this question. Is there any contribution of those cause variables on the effective variables we have? Like the regression we did, the effective variables we have here is what? Who knows the effective variables on this regression? No. This is an edge because it is outcome, what we call dependent variable. We are trying to see how edge is going to behave when we are considering systolic, diastolic, treatment cost. It is an assumption we take. That's why it is going to be complicated to interpret it. But try to understand the logic. Yes? We are trying to see how edge is going to behave when we consider systolic, diastolic, treatment cost, and recovery day. As a cause, let's assume to have an edge, you must consider those kind of things so that we can determine your edge you have. Let's say we have a class here, but I don't know the edge you have. But for you to know the edge you have, I need to first look for your systolic, diastolic, treatment cost, and recovery day. Yes, that is what the regression does. And then when we say that, as I told you, for us to be able to interpret this result, we started by looking on the p-value. Like, is there any relationship between these variables that I'm dropping? When you see that the p-value is less than 0.05, that's where you will try to see, yes, there is a relationship. There is a contribution of historic, for example, for you to determine your age. That is what is going to come in your mind when you see that the p-value is less than 0.05. But if you see that it is higher than that, there is no contribution on that variable to determine your age. Yes? But we have taken an assumption because all the variables we put here, there is no relationship between those and the age. And we said, let's take an assumption where the recovery day, it has a p-value which is less than 0.05. Yes?
When it is less than, meaning?
Less than,
Yeah.
lower than that. Okay. The levels, we have what we call level of significance. It is, by default, we have 5%. What this 5% means, I thought you know what it means. We have also the p-value, probability value. So let me explain this. So the level of significance, what it means in real life, when we are doing a research, we normally we can do an error, maybe through the process of doing data correction, analysis, whatever. But we said for us to recognize that error we can do because we are human, 5%, it is an error we can tolerate on the result you are providing. Yes?
Yeah.
During the process, which means the result we provide, 95%, it is going to be true. At least 5%, it is an error we can tolerate on the result you provide. And when we are looking for the p-value is an error we made. For us, the error we made during, like, from where we started, maybe we decide we designed the sampling in a wrong way. We clean the data in an incorrect way, for example. So for us, when we are seeing the p-value, understand that it is an error you made based on what they can tolerate on you.
So this is the benchmark.
Yeah, this is the benchmark, actually.
Yeah,
And this is the actual error you made. That's why we compare the actual error we made and the tolerated one as a level of significance. So then when we see that, for example, we have 0.0 something, like we have 0.47 something, it means that here, when this is on percentage, and here when we put in decimal, we have 0.05, something like that. But when we have 0.047, it means that it is 47%. We made an error which is higher than the benchmark. Yes? And the way we take decision, we say, if the error we made as what? As level of significance. So if the error we made as a p-value, because the p-value, it is the error we made. If the error we made is less than tolerated one, or benchmark, as our father said, maybe benchmark, something like that, as a level of significance, we rejected the null hypothesis. Yes.
And then what's the round related what? We should be greater than or less than what? We should go below what? We shouldn't go below what?
To go below, it is the correct way. Like,
No, we shouldn't go below what for this case. for p-value, it should be equal greater than what?
0.05
0.05
as a benchmark.
as a benchmark.
As a bench, that is the tolerated one. We cannot go above. By default, in Rio, right. But when it comes to the medicine, something on the life of people, they said 1%. They say, for example, you are doing some surgery, and then you say when you do 5% of doing a surgery something. That's why in medicine they used to take 1%, but when it comes to the real like other kind of field like education, business, we say 5%. But when we are doing testing in medicine, we consider 5%, 1%. Yeah, 1%. And when you see, okay, lunch break, I add 11 minutes. So let me, okay, let's resume afternoon to explain it. Yes? Yeah, let's resume afternoon. Sorry, I wasn't seeing it. So let's resume afternoon.
Yeah. So we are going to break for 1 hour for lunch. And then from my observation, things got complicated along the way. So what we are going to do, this is the analysis. When we say analysis, this is what we are doing. It's the descriptive analysis, this inferential analysis. When you do cross tabulation, summaries, and everything, that's what you put in your reports. At the end of the day, that's what your boss is going to be looking for. So to make things easier, we are going to have the afternoon introduction on how do we use AI to handle all these coding things. So your part will not be about memorizing codes, but more about where do I use this code, right? And from there, we're going to have an exercise, a group exercise on some tasks of analysis. So we make sure by the end of today, as we proceed into the next week, you have a practical example of what the analysis will do. Right? Yeah. So we're going to go out for 1 hour and then we come.
So people online, are you hear me? Mhm. So let's resume. So we are going to resume on the things of inferential statistic, a bit on regression analysis. And after that, we will see how we can use AI for doing analysis as well. So we stopped on regression analysis, where I was explaining how the regression analysis should be interpreted. We have seen about the level of significance, and yet we have seen that is a benchmark, the error that we can tolerate in any field without considering medical field. Because on medical field, they take level of significance as 1%. When it comes on mixing, involving the life of people, they are taking the level of significance as 1%. But other side, by default, we consider 5%. That is the error we can tolerate to the entire research. When you are doing research, from where you think about the problem, you design the questionnaire, design the proposal, whatever. The 5% goes to those processes. And the p-value, it is the error of this error we made during that process of doing analysis. And when we are doing like the conclusion about testing, we consider the error we made and the acceptable error and the tolerated error. That's what we call the p-value. It's an error we made, and the level of significance is the tolerated error. Since we have seen that the error we made is less than the tolerated one, it means that we have done amazing work. That's where we reject the null hypothesis. We always come to complement on null hypothesis. We have what we call null hypothesis and alternative hypothesis. Okay. Null hypothesis, we type it. Let me come on code. That's it. So we have, can I type it here? We have also null hypothesis, HO. Those are testable proportion, something. It is a testable something. Like you can say there is no difference between salary and gender. That is a null hypothesis. Null hypothesis. We can take an example of there is no difference. There is no difference between gender and salary as an example. Or based on the data we have, let's take based on the variable we have. There is no difference between salary and smoker. Sorry, between gender and smoker. That is the null hypothesis. And you start complaining. That's why there is alternative hypothesis. So our side is alternative hypothesis. We complement on the things that is there. If I come and I told you there is no difference between smokers and a gender, and for you in your mind you have that many smokers are a male, yes, but you don't have evidence. That's why you come up with testing hypothesis.
Then what about salary and smoker?
Sorry, I guess salary is not here. There is no difference between gender and smoker. Yeah. Is it true or not? We don't know. That's why we test by using chi-square, because this is a categorical variables. We do chi-square to look for the p-value. Once we see for the p-value is higher than the level of significance. It means that there is no difference because we failed to reject the null hypothesis. So we then H1 will be there is a difference.
Difference or difference?
There is a difference. It's fine. How you can? There is a difference. This one. There is a difference between gender and smoker. So if p-value is less than 0.05 as what we call level of significance, we reject H0. Otherwise, we will accept the null hypothesis. If we fail to reject the null hypothesis, it means that we don't have enough evidence. Because normally a person, as a researcher, we always support alternative hypothesis. Yes? You are not getting it. It is confusing. Okay. Try to ask so that they can know where. Okay. Yes?
I think when we want to understand where this kind of null hypothesis and alternative hypothesis. So suppose let's try to relate on the court, the crime, criminal what and what. So when you are under the court, so a judge has to take you as you are innocent, unless there is evidence.
Until you're proven guilty.
Yeah.
Yes, unless there is evidence that shows you that you are a criminal. So the way a judge take you as an innocent,
It is
what we call
null
null
hypothesis.
Under the court, every person is innocent.
An innocent.
Until one proven guilty.
And then when you want to
prove it.
to prove it, you have to bring the evidence. Those evidence are Bivariate.
A good illustration.
Yeah.
Okay?
Yeah, that is a good idea.
And then, yeah, the prosecutors are the one to say, okay, this is the evidence. And then the judge has to take you as an innocent, unless there is evidence that shows you that you are a criminal. So the way a judge take you as an innocent, that's what we call null hypothesis. Under the court, every person is innocent. So when you want to prove it, you have to bring the evidence. this
P value is
person
greater than or
is
greater
not
than-
Yeah.
innocent.
Yeah.
That's where the alternative hypothesis
Comes.
No, when evidences are not enough,
When the evidence are not enough, and then
You
we
are
going to
innocent.
support innocent.
Yeah, you are
When the
innocent.
evidence are enough,
Enough
then we go with your
alternative.
That's the simple way to understand.
I think now it's
Yes,
clear.
yes.
Yeah.
Not a
Thank
that one is from which subject? Statistics.
This is a statistic. You think from you're thinking from medicine? I was thinking from it's a new medication. Okay. So, and that's where I said before you take the conclusion, you have to look for the p-value, the error you made. And once you see that the error you made, it's higher than what is tolerated, nothing you can say about the independent variables on the contribution of the dependent. Like it means there is no influence of these variables on age, because what we need to see, it is a contribution of those independent variables we listed here on the dependent variables as age. For us, we take age. At the starting, we was interested to see if there is any influence of systolic, diastolic treatment cost and recovery day on the age. But if we see that the p-value are higher than expected, it means that there is no contribution of this variable on age. That's how you will take decision. And unless you see that there is some variables has a p-value which is less than tolerated, you will go with a coefficient to interpret to what extent. So here we will say for every day increase on recovery, age will decrease by this year. Maybe this should be month, whatever. Because we have a negative, that's why I say the decrease. But if we have a positive, it means that age will increase. That's how we will make interpretation. So I think from here it's clear now. And on regression, especially other thing which pays a lot, it's what we call R square. R square, it's what we call coefficient of determination. Coefficient of determination means to what extent those independent variables, when we combine it together, explain the dependent variable. Yes, we interpret the coefficient of determination as R square by taking this value multiplied by 100. If we take this value, m come on Excel, and then let's multiply by 100. Let's assume that those variables, there are some which is correlated. So from here, because I multiply by 100, I can say that those systolic, diastolic treatment cost, and even which one? I forget. We have systolic, diastolic treatment cost and recovery day. It is explaining the variation of age to the extent of 0.59%. Yes, that's how we interpret the R square.
combining all.
Yeah, combining all variables as are independent, it is helping us to explain the age or dependent variable to the extent of 0.59%. So just R square tells us to what extent independent variable or cause variable explain the effect variable. Yeah. That's where it will come up. And
But
you
it is
see,
one element also, we can also conclude.
okay.
It doesn't mean we should have many elements that should be combined enough to explain coefficient.
You can also,
have
okay.
one element.
You can also have possible one element. We started, I remember I said when we have it as one element, it is also what we call simple linear regression. where we will have one independent variable and one independent variable. So if we have it as one, let's take an example to treat all those we have here. Let me treat this one. Why this is not treated? I was treating the outcome. That's why. If I come and treat this one, this is going to be simple linear regression because we have one dependent variable and one independent. The output, the p-value still is higher than 0.05. And from here we will say historic, it is explaining when we consider the R square. We take this and multiply by 100. We say that age is explaining, it is explained by historic with almost 0.005%. You see? Let me type this one. We will say approximately if we multiply by 100, we are going to see this one, 0, almost a 0. 0.5% of the variation of age. Variation of age is explained by historic variable. You see the change of age to the extent of 5%, 0.005%, it is explained by the historic.
Is also compared to the level of significance as a big.
So you can't like for us to be able to interpret this, like to provide this statement, normally because the p-value it is higher than what we expected, this result can't make sense in real life unless the p-value here is less than 0.05. That's why you can't come and say the R square, even though the R square should be 80%, for example. Let's assume R square is 80%, and yet the p-value is higher than what the benchmark. This result cannot be acceptable because we made a mistake. We made high error than we expected because the p-value, this is the first step we look. If the p-value is higher than the level of significance, it means that we made a mistake than the tolerated one. Means that the other thing we can do, it is not acceptable. Yeah.
So we should always
focus on the p-value first.
P-value instead of other.
Yeah. Focus on p-value first. Others will have the additional explanation. Yeah, that's where we will validate it. But if the p-value is not validating it, nothing you will do. So I think this is enough.
And,
yes.
I'm not seeing why now those estimates, standard deviation, errors. Why now the machine is bringing all those?
Okay, for us, like let's assume we have an error. Like this is a p-value. For us to get a p-value, we will need estimate and a standard error. So the error is also, even this is a standard error, it's like a standard deviation. We normally know in real life. When we are doing the standard deviation to the entire population, like if we are calculating a standard deviation by considering the entire population, that's where we say standard deviation. But when we are calculating standard deviation to the sample data, it is coming with the standard error. So this is the standard deviation. So, and if you see that the standard deviation, where do we have a mean and the median? Something like that. Those are the things we combine so that we can get this p-value, but also for us, when you go in statistics, sometimes we make interpretation by using t-value here.
T-value.
Yeah, t-value. This is there is a lot, but consider the p-value. I don't want to make much effort on this because the standard one, it is a p-value. But for me, I can also take decision by using t-statistics here. Yeah, but the best way is this, leave it. And then other thing, maybe I didn't mention, you see, when the p-value is less than 0, yes, the R is going to bring the p-value by adding this dot. If you see on the result, like see here, we have a 3 dot here. It means that the p-value of this value, this is 10 times negative 16. 0.000 something like that. When we have this one, it is like 2, it is 0.0002 times. It's like we write 0. When we have this one, it is like we have a 0.00 something like that, 2, something like that. That is the p-value there, where we have this one. If we have e power negative 16, it is 0.00 something. And now you see the p-value is less than 0.05. You know what? Because it is less, because this is an intercept. Intercept means the value of edge without considering other factors.
And you don't consider other factors, meaning
Yeah. How many, let's assume, let's take an example. We are in a class here. How many edge we have without considering other factors?
You count the people, then you know how many age, like you.
Average age, for example, average age. How many average age? What are the average age we have in this class without considering other factors? This is the intercept. Normally, when we are writing this model, we used to say this is beta 0. So you used to see this. This is beta 0 plus beta 1 x1, means that beta 1 is coefficient of first variable, x is take it as diastolic, x2 as diastolic, x3 as a treatment cost, x4 as a maybe recovery date. So then, for us to see the value of y it is edge to our case, because y it is dependent to our case. Edge is equal, putting on our case, this is called B0. So normally, you see the estimate here, it is 52. The average age of those persons are a 52 age. You see? Because this is the intercept. The average age of those people, without considering other factors like diastolic, whatever, are a 52 years old. But when we consider, when we add this variable of diastolic, age is going to decrease, you see? It's going to decrease by 0 point something. This is the coefficient. We take this coefficient, multiply by 1, because we look for, by adding one diastolic, like maybe diastolic measures, like when we go on the data and we take, see the idea here. So when we go on this data, I want you to see the idea behind. See here, like when we say by adding one something, let's look at the diastolic here. See here, when we take each value here and adding 1, by default when we interpreting this kind of thing by adding one. Here we have a 157, but when we add the one, it is going to be 158 to the entire data set. The edge or edge automatically is going to be decreased by what? Is going to be decreased by 0.02 for every edge we have on the entire data set. But when interpreting this, we are looking for average variation as well. So that's where we will interpret this kind of thing. But always need to look for p-value because this estimate cannot have meaningful if the p-value is higher than what we should have.
And the degree of freedom.
So my friend of mine used to give me an example, like if you are dating, sometimes a man can date with 5 girls, and when they lose one, they are not going to suffer.
And even an example.
You say, I can date with 5 girls, but if I lose one, for me, I'm not going to suffer because I have 4 remaining. That is the logic of the degree of freedom.
No,
Yeah.
No, that's opposite.
But I'm using that.
You can't have now in your data set. So you must find like 2 million
Like I'm taking an example of that, like to give when we are running this kind of statistics, like if we say the degree of freedom, like it's like assuming that where are we free? Like if I have a 4 and I lose one, at least I'm not going to suffer much. I will suffer, but not much, because I remain with 3 people. Yeah, that is the logic. I don't know. Even me, I don't have one. But if I have a one, if I have a one and I lose that one, I'm going to suffer. But if I have a many and I lose one, I'm not going to suffer. That is the idea of the degree of freedom.
To take the degree of freedom and p-value, there's something now that can be, there's confusion somewhere.
So,
for example, degree of freedom.
This is a degree of freedom.
Yeah, and the p-value is set.
This
so
one.
That someone, he gives now room to do a research, considering that a certain amount is tolerable. When, for example, you fail
to reject.
Yeah, to reject. And the degree of freedom also have a certain degree of freedom to do something. I don't know if can be compared with.
So you are free to do whatever you want to the extent of 609, but make sure in everything you are doing, like you are free to go anywhere. But let me give you an example. As your father, you have a child. You used to say that do whatever you want, but don't exceed to this level. Yes? This is the degree of freedom. And there is something you said. Maybe when they violate it, you will impose some penalties to them. That's why the degree of freedom, sometimes, let's say we have 100,000 observations. The logic of calculating the degree of freedom, they take, if we have 100 to something observation, when we are calculating a degree of freedom in statistics, we take this -1. Imagine. That is a story. I don't know how I can interpret it, but take it like
It's n-1.
Yeah, n-1. That's why I said n, it's a number of observation. Yes? Mm-hmm. Minus what? Minus 1. You see? This is a degree of freedom. It is going to be 150 something. But the idea behind it was an example I gave you when I'm dating 4 girls and then I lose one. It's like the assurance of mindset. Let's assume like that one. Maybe we keep it aside. Can do the further research maybe to complement on the p-value. You can based on that and then you criticize. That's what I can give you. But from here, I think the regression, you understand it. So now how can we use an AI to do the analysis? So the way you can use an AI to do the analysis, it is start by importing the data set. Of course, you have the basic thing you can do yourself. Yes? Maybe let's open the empty R script. Let's open the R script. It's fine to open the R script.
First import.
You have to import the data set first. Into R. Into R programming. But there is another thing. You don't need to play with R as well. Like first you have to be you have what you want. Yes, if you have a data set, sometimes they give you the description of that data set and you know the objective of that data set. We are going to take an example of this data set of patient, and when you look at the variables that compose patient data set, that's what I'm saying. Patient data set. There is a data set that we are using. That's what I'm talking about.
Patient. Okay.
Yeah. So you need to understand the data set first. The objective of correcting that information, what you want from that data, so that you can use an AI to generate a code. Yes? And then after, if you understand the data set and objective of the data set, and the reason why you corrected that information, you come up with saying that we are going to import the data code patient as an example. Patient from there. How are we going to import it? We say read.csv.
Read.
The way we import the data, it's read for .csv. Is it true? Then you come up where the data is located. For me, I have it where? On data. For you also, you can do it the way. I have patient raw data. Copy as path. Can paste it here. For me, it's going to give me the entire path.
It's called patient.
Raw data. It is the data set Dr. Rema sent it to you.
Patient equals read.
And then you change this path, this forward slash into backslash. And that is the best way also we will use when we are designing a dashboard in Arab programming.
Do you have that data?
Yeah, we have it. Actually, that's what we was using. We are using the patient V2, but comes from the patient data. Please try to be on the same page because has everyone imported the data already?
Not yet.
Did you import the data or not?
Please crypto, please crypto. No, no. It says crypto. What is it?
Even as other master, you can use it.
If you go to script,
I prefer RStudio. Then you can use control in. Put the cursor control in. Yeah. When you use the transcript, okay, everyone has imported the data. Yes, let me come. New operation. Assignment operation. Ariko wakoresha na bihwanye. Wakiramo iko, wakiramo karindwi. So, if I type patient and then I put enter, you see that the data set is coming. Type the patient in below and then you run. You have to print the outcome.
Patience.
The way it is typing. Control enter. Don't say enter. Okay. Okay. After doing this, we are going to use what we are going to do here. It's like you can clean these kind of things. To clean it, you come here. Can you follow, please? If you don't follow, maybe you're going to suffer. You clean it here. For us to have, I said here. I said you come here and then click on this.
Where?
Sure. Clean it. Okay. Then the first thing we started with, it's like using a structure code. Structure. For us to be able to know the structure of the entire variables we have in a data set. You have a patient. We put the name of data set, and then we run to get the structure of data set. Once we get the structure of, it is a structure to look for the structure of the data set. You forget. I'm not going to clean. I'm trying to show you how you can, because you can't go on AI and ask AI without knowing how many numerical variables, how many categorical variables. It's like start by exploring the data set. What I'm doing here, that's what we will copy and paste in AI. Try to ask the questions regarding on your data. Yes.
Right in front of patients for format of explanation. Sorry, space just for you say comment. Just put the comment.
Okay.
In front.
Okay. You want me to say print?
Yeah. You see, you've written the patients. Say
But I thought you know, this is
No,
how
no, no,
this is how to print the outcome.
But it is control enter. Yes, yes. It is control, yes, it's control enter.
This is how to
No, you know this, you are laughing at me, but the first time you are not laughing. You don't laugh at me.
you can okay, you can let me document it. You can you can use control plus enter, something like that.
It is like that, it's not something like that.
No, like when I'm saying this, I thought you can write a print. When we type the name of this, you can also write the print. You understand? Because if you do control enter, it's to run a code, not these kind of things we have here. That's why. So if you want, you can write a print and then put the variable, the name of the data set, then you run. But if you type the name of the data set and then you run, control enter, it is for running a code, not for printing the outcome. That's why maybe to type it here doesn't mean anything. This is for printing outcome. Because you can also say print, and then you say patient, and then you use what? Control enter to run the code. The control enter, it is for shortcut of running a code. Yeah, something like that. And then when you need also to get, before you copy everything and then you put on AI needs to know, I have variables like this. This is a numerical, this is a categorical, whatever. Yes? This is not markdown. This is RScript. Yeah. But the code are the same. Yeah. And once you get its structure, what is going to help us when we are asking AI? Because it knows that age it is a character. Yes? It knows that when we get the structure of the data set, it already knows that age it is a character. You see? It already knows that age it is a character here. And yet it cannot go directly to calculate the average without cleaning it. You know what?
Yes.
If they know that to get the structure of the data set, you see here we have age, the data type, it is a character, and normally age should be numeric. And when we copy this and then we put on AI is going to know that even though I will need to calculate the average age, first, the age it is a categorical. I can't calculate the average age of categorical variable. I have to start by cleaning it to convert it as a numeric. Yes? Yeah.
So
And yes?
Sorry to bother you. Can you maybe the heading working with AI to be clear?
Working with AI. Okay.
People are laughing at me because they're experts.
How can we use AI in data analysis?
Yes.
By using other programming. So the way we are using it here, you can also do the same in other markdown because the code are the same. Yes, the code are the same. So then, after getting a structure, there is another code I use to run called Grims. Grims, it's a print. Grims. Grims. This code called Grims. It gives us the entire data set and their values, sample values, like the way the responses is recorded to each and every variables. Let me put the comment. Grims showing us how records are recorded for each and every variables, not for every columns. If I say columns, just understand the variables. Yeah, like Grims. You have to package code. You see, if I run Grimps and then I put the name of the dataset, he told me that we have how many number of observation? 611. You see, how many columns we have? We have 16 columns. The first column, it is a character, and this is how it is recorded. This is the responses as a sample. They gives you the sample response for each and every column. You see, this is how patient ID, this is how full name it is, this is how age it is. You see?
Sorry, for those new, sorry, Tassie,
Yes.
there's library saying you have to run fast.
Mm-hmm.
Yeah, so put it there, because, no, put it there, because it's very important.
Mm-hmm.
Put there.
So when you are importing data,
Tell us the packages that you have to first. Packages that are needed to input data.
first package, it is what we call, you run library, you put also tidyverse as well. You run it. Also another package called
DPLY something.
this one, DPLYR. This is for data manipulation. Okay, this one. Okay, then this also
DPLY.
cleaning. Okay, data cleaning as well. Because inside the tidyverse we have DPRY something. Tidyverse, it has almost it's almost 10 packages inside there. From there we are okay.
Showing us just it's single R, not double S.
Well,
113, on Grimps, the explanation.
Grimps showing us
Single
how records are recorded for each and every columns. After doing that, you can also do names to see the name of a data set where it is written. Are they currently seeing my screen? Benjamin, still seeing my screen? Okay. Another code we will need. Everything that we are doing here, it's in the sense of getting enough information to the data set. Then we say patient. We put name, not the name, to see the name of the way variables it is written. You see, if I type a name, I will see the name of the data set, like the way it is written. From here, I'm done with what I will need to tell AI so that they can understand the data set. Yes?
So you should know, for example, if you're given another data set,
Mhm.
you have to name all the columns.
No need to name it because every data set should have
Its own
whatever. So what you do first, you import the data. You do structure as we did. Then you do grim to get how the variables is responded, like to see each and every response. If we do grims, they are giving us the sample of the record we have to the entire variable. Yes? After that, you can also know the name of the variables, the way it is written in R programming. Yes? After that, you have to copy this. That's where we are going to ask AI. So we come here,
Where?
copy the output.
For names for the patients.
Start from this kind of thing. This do you run, please? Run first.
Yes.
So then copy this. If you copy this, you have the variable, you have the structure, the way the response is recorded. Then you go on AI. You copy, yeah? You go on AI. So ChatGPT.
No, I mean, copy this.
Control C. Select and then do Control C. Here chat. Then you come and do the prompt. So when we are doing a prompt here in AI, there is a 4 thing you need to know. Like first you start by telling an AI a content. What are you going to work on? How AI is going to respond you, like is going to act like that, like a certain person. Let's for example, we are using an AI, like we are going to give a content we copy from Ara. Hello chat, look at this. See the prompt I'm going to make. Look at this information here. So this is a DeepSeek. For you can use ChatGPT.
Look, Hero chat, look at this information.
Yes.
You copy and paste.
Yeah, you copy and paste. Yes. Even the ChatGPT, copy and paste. It is the same. Yeah, it is the same. You want me to use ChatGPT? Okay.
Hey, it knows it is error.
Why? You already ran.
No, how can it know? It is me, it is that another things.
You guys, you already put in enter. But I want you to paste the information first so that we can tell ChatGPT what is going to do.
I thought they have to enter.
No, enter for what? Because you didn't tell ChatGPT what is going to do for your data set.
So I can clean it now.
Okay, it's fine. You can add another page here. You chat. Hello chat, look at this and then paste that. Okay. Yes. Hello chat, look at this information and then act like data analyst. Act like data analyst.
That analyst.
Specialized in what? Clinical, because this data it is for patient. That specialized in epidemiology content. Epidemiology content, and then after you have a given a job to do the analysis.
Yes, that's what I want.
Tell ChatGPT who you are and who are going to do that kind, so that they can know which person are going to perform this kind of task. Because you can't copy and paste it there and AI is going to know what it's going to do.
I know.
Because you are epidemiologist, that's why they give epidemiologist, a person who deals with
get data that all of us can understand, like maybe like for university data.
Okay.
Like this for get an example that is understood by everyone.
Okay, let me do this fast. We have student data. Are you okay with student data? Okay. What if others are not a student? They are going
Everyone
to
pass through this session.
But you go to the medicine to search for medication. That is fine. I'm going to use the student data after this one. Yes?
Yes, yes.
Yeah. From here, after that, you say, hello chat, look at this information.
Look at this information.
Hello chat, look at this information, and then act like data analyst specialized in epidemiology content. And then after, do the analysis from screening up to
Then act like data analyst specializing in what?
epidemiology, explanatory data analysis, and even some inferential statistics. Tell Ara what you want. And please use a simple code. Please use simple code. If you don't say use a simple code, it's going to generate a code, and then you see that this is a magic.
From cleaning up to
And
analysis.
Look at this information, then act like
Cleaning.
specializing.
from cleaning, this is a cleaning.
Cleaning.
This is a cleaning. It is use a simple code and even add comment on each code for me to understand it. You see the prompt? Hello chat, look at this formation here, and then act like data analyst specialized in epidemiology content. And then after, do the analysis from the screening up to explanatory data analysis, and even some inferential statistics. And please use a simple code and add a comment on each code for me to understand it better. Mhm.
Yes.
Let me copy this and I send to Fabrice to share in a group for you to simplify the work. You see? Fab, can you check on your email? I send it, and Fabrice is going to share in your group WhatsApp so that you can copy that, you paste it in AI. But in general, what we are trying to do here is when you are playing with AI, there is also prompt. Yeah, you have to be brief to tell everything, whatever. Even if you have a questionnaire where the data comes, you copy the questionnaire, you paste it here so that it can have full information. As you will need to understand the data before you start, AI also need to understand the data, even the objective of that correction of that data. AI will need to understand that kind of things. As you also have in your mind, try to put everything you think that AI will need. Take an AI as a person. Let's say you give me a job to do the analysis, you will give me the brief introduction of the assignment. And take an AI as a person that you are telling a brief introduction about the assignment that are going to do. And then you are done. So, but make sure you do those manual things we have done before. Here, manual thing we have done by importing the libraries, and even you can copy this to give an AI so that they can see the path of the path where the data is located. You see?
So you have to copy and paste it.
Yeah, you can copy the starting code, and then here you can say here is the sample code we have started using as here. You see? Then help me, please. Then you run. Once you run, you see what happened. Comprehensive epidemiological data analysis of patient record. This is the data loading and initial inspection. You see, because I told AI to add a comment for each and every code that is writing. You see here, loading required libraries, tidyverse for comprehensive package for data science track, deep ROI, data manipulation and cleaning, rubricated, working with dates. Those are the packages Dr. Emma yesterday said. You see, AI also knows that you are going to need that package. And this is the way also to import the data, GRIMP to view something, data cleaning, you see. Those are the data cleaning. Those are the code you can run for the data cleaning. Imagine from your mind, you see. Are going to suffer, you see. Explanatory data analysis, you see. You see. Yeah. And this is the summary. After giving you the code, this is the summary of what AI does for you. You see, AI, it is starting number one. It is started by doing data cleaning. They take a data and then it started by doing the data cleaning. It has handled inconsistent formatting, missing value, and standardized the variables. After that, it does summary statistic of patient demographic, outcome, and clinical metrics. Then after, it has done the visualization to see the distribution of pattern, relationship, and trend in a data. After that, it does statistical test. Did you use the same thing I used? Sure.
You copy and paste.
The same form.
The same way.
No, it cannot give the same output, but it has to give related things. See, that's totally different.
Yeah, it is the right thing.
No, this is the right thing. It is giving complicated things.
It is giving you complicated things.
No, it's complicated things instead of.
So if you ask the AI
Sorry.
in an incorrect way, it is going to confuse you.
No, this. No, it's
And then we didn't get
He posted the whole script from day one. From one class number.
okay.
It will help some.
Yeah. Show me what you did. So you come here, do this, you copy this, something like that. It's good control C, paste it again. And wait, paste it, put a space, paste the comment I gave you. And now to see. You forget to add the sample code you have run.
It's not fun. Okay? Just make me.
Okay, you already copied.
No, first copy that stuff. No, copy this.
It's fine. And also here is the way data it is.
Yeah, also here,
With AI, we understand. Because he normally knows, even in advance. You put here, and you can save, and here is the sample code. Print. I need to copy this sample code and send it to this one. This one you run. Then see the result that I'm going to do. So if you
Sorry, what is the sample code? There is this output here. You have copied.
this is a sample code that you have run so that you can get this.
Take it from above. This, you copy this, copy this, and then there's a sample code.
It's like the way to document the issue you have. Like if you have an issue, you know the way you can approach someone to support you on that issue. Think of like that kind of thing. So did you get at least something refer to what I see here, or I'm getting, you get something really similar to this one, or you are getting your own stuff? Okay. Is it not the same?
Now, what will be the result now?
Let me show you.
No, listen. Copy what? We can almost get a copy.
Okay, you see, for me, I have data loading and initiation inspection. If I copy this, and then I come,
Which one?
this one. If I come here and then I say copy. If I copy, and then I come in R, even this one I can read. I write here, I can read, and then I paste this one. You see, if I copy and then I run everything, you see everything is going to run. You see, I'm inspecting the data, and then I come again on DeepSeek. I go on the step number 2, data cleaning and preparation. I copy the code. I go in RStudio. I paste the code there. You see, this is the code. Imagine, you see.
All of the thing.
Data cleaning and data transformation from here. When I run, everything is going to work. You see, everything is going to work. You see, until checking a missing value. You see, in a missing value, what I have, column sum. That is the missing value on this day. And from here, once I see that there is a missing value here, because I want to replace those missing value in my analysis, I can copy this outcome and then I put on AI and I say update the code. You see? Yeah.
PTC.
If I come here, you see that I check the missing value, and I have seen that there is a missing value in my code. Let me cross this, and then I do this, you see. Let me copy this one. Let me select this one. You see, if I select this one, and then I come here, I say update from step 2.
Form.
2.
Form.
It will understand. I know. It update from step 2. You see.
Step one.
You see. Missing value, whatever. You see. To rower, to string. Those are the codes we have run from yesterday. Cleaning blood pressure, handling empty value, and extract component, whatever. Those are the things he's doing for us to be able to make sure that all the data are clean.
What's the result now?
The result, we are going to see it once I copy this code and I run. You see, I import the data. So I can come from cleaning the data set from here. Of course, you need to know what you are doing.
What?
I'm copying the code, this one, from here. So once I come here, and then I paste it here below, and paste it from here, I will come on 100 and something. Imagine the code 100.
Realize the amount of coding you're supposed to do.
And then, how do you run that one? You
Control Enter.
without selecting.
Yeah, you can do Control Enter, you see, whatever, you see. Nothing, okay. I continue checking now. On edge, there is no missing because I have already, you see, the data quality, you see, all variables are cleaned now. Missing value, the total record, you see, percentage of missing, unique something, how to handle it, missing edge by outcome, you see. Those are the things you can do. From here, you can continue play with the data. This is a summary statistic, whatever, you see. You are done with the summary statistic, standard deviation of age range, average recovery, standard deviation of recovery, whatever. Those are the summary statistics you can do for the numerical numbers. Now, once you are done with summary statistics, remember my code, sorry, DeepSeek, because for me, I'm using DeepSeek. I can, can you always use GPT? Okay. So you have to train it. Ask and more and more. AI is going to. So then, now the problem comes. We are asking AI both of us, but we don't get the same result. It is also the same case when you are going to. Okay. Summary statistics from here. If I do summary statistics, see the result I will receive. Control Enter. If I print, you see summary statistic, outcome, whatever. Those are outcome distribution, deceased 151, ongoing 167, recovered 210, unknown 83. And you can continue on gender distribution. We have female and male and not specified. You can also come.
So wait, what's in?
Number of observation. Yes. Here, outcome, average age per outcome, you see. This is the thing they can do for you because they think like epidemiologists and then they do the analysis you must need. And if you have a questions to answer, you will paste that questions. AI will go directly based on that questions you have. So smoker, whatever, something like that, you see. From here, top, you see. Look at here, top 10 most common diagnoses. And we can't imagine to do how we can do it. But AI can think like something like to tuberculosis, pneumonia, something like that. They think like malaria, this is number 10 about diagnosis. They can also do hospital performance analysis. You see, let's look for the hospital performance analysis. Hospital, you see, those are the top 10 hospitals. You see, the hospital that has this code H005, it has 42 patients. Recovery rate, it is 64%. Mortality rate, average, mortality, and the recovery day, average cost, it is this one. You know, that is the analysis mostly we can need on this data. So then you can also come, you see, this is also what we call insurance provider analysis. They did analysis, amazing analysis for each and every stuff you can do. So from here, what I can say, because for me, maybe I'm using AI more than maybe I used when? From 2000 something, 21. Okay. But for you, what you need to know, since it's the first time you are using an AI for coding, can you pay for CROD? Maybe they can pay for CROD for you to have it same profession. But how much? 30K per month. 30K per month. Yeah. Almost 32,000 per month. It's an AI called CROD. Yeah, it is good on coding. Yeah, but also
You can't get it for free.
there is a free version. But if you need to use it more, like imagine when you are doing a dashboard, you have to pay sometime, but not always.
Always.
Not always.
It gives you sometimes when the plan is expired,
Mhm.
that
Road.
Yeah.
So, but it's simple. The way you are using there is enough.
What I was
The only problem it will be when you give it to produce everything. It will be an issue. You won't even know what's produced. But once you go import, ask, I want to clean like this, gives you the code, you paste it, you see the results, you continue cleaning, acting like your advisor, not doing it at once. If you work, it will work great.
Yeah.
Let me
You
give
can't
you
expect it to be doing it at one glimpse. Do everything. So once you work with it, it's okay. That's fine.
That's what he has given.
It's fine.
Okay. There is also another chart for me because they give me the explanatory data analysis and even here gives me the code of data visualization. I can copy and then I paste it here and then you will see. Cannot do the visualization by using this code. Yeah, this is also the visualization. If I run this, you see the chart now. The chart is going to come on this side.
What did you do? Sorry.
This is not a good chart. You see? This is deceased. You see? This is treatment cost distribution. Deceased, ongoing, recovered and unknown. This is the dis. Okay. This one. This is also not specified. This is a smoker, and you will need also to have the percentage. You see. This is also the correlation, whatever. Those are the things you can do by using an AI. Let me know if you get something at first on using it. So you can see, make it more professional, please.
Yeah. I got this. Okay. And the other one is late. Shift enter is not going on. Yeah, that's more. That's not the yes. Okay. Sure.
Not working. It is a French air. French air. Is it a French air? Let's say put it in a French and then you see.
You just have to be clear. Clear with your AI. You don't expect it to know something you didn't tell it.
Put in French. You see? If I say put in French, it is going to. I know. This is a French.
No, it's not an issue with the AI. You're using which AI?
Can I use ChatGPT and then you see? Like what we can say, it's like make sure that what you communicate, at least put every information. So when I change to let me use my AI ChatGPT and then you will see. Not an issue. Even the DeepSeek is free. You can also have it. Let me use ChatGPT and then you will see. Hero Chat. Even when I'm using ChatGPT, see. DeepSeek is free. Anugija issue. So you see, let me use, okay, let me clean this one. And I start, and then I use ChatGPT to see. So I run this. For me to get the explanation on the variables, I come here and then I select this. That's what we did first. I come here. This is a ChatGPT. I paste it here. And then after, look at this here. Which one? What I sent to Fabrice. This comment I sent. You see?
Yeah.
What I sent to Fabrice. And then once I come, make it better praise. Let us see.
Simple.
This is my GPT. So this is how it does. It is loading the data. Let me hold on. Part number 2, missing value. I'm checking the missing value. Okay. Let's finish fast and then we see. You see? This is creating edge group. You see, it is telling everything you can do, like creating an edge group. Maybe you are interested to represent the edge group instead of saying average. For example, they did it for me, 0 up to 17, they call it children or adolescent. And from 18 to 29, it's young adult, 13 to 44, middle age, older adult. This is what it did here. If I copy this, imagine when I say, let me copy this, for example, and then I come here on Excel, sorry, not on Excel, on R. So let's say, let me paste it here. And we are going to see that when I run, you see, when I run this code, it is going to work. And when I do tab, you see, when I do tab, this is the result. So the problem, it is not an AI. It is the way for you, you want it to do your kind of analysis that you're doing. And at least make sure that's why we started by playing with it, by not using an AI, at least to know the error, like to know how you can code the simple code, to be interact with like the error instead of relying on an AI. And let's say something like sometime you can code and then you get an error. Yes, let's do the error by ourselves. Let's do something like this. Let me remove E here. You see, we have table, something like that, but let's put an error or extra something, and the AI is going to give us an error. How can we handle an error by using an AI? When you type a code, for example, and then you get an error. Because normally we know that when we are using a tab, we use table, not table to something, and I add the numbers by default, like I myself, to see where we can handle an error. So you copy this error first. You look at this here. You look at an error first. You copy it. Then you come. Look at this. Error here. And correct the code. And then correct the code here. So you will come and then you copy the code you are trying to write. You see? That gives you an error. Then you come here, you paste it, and then you run. Once you run, you have to wait. It is going to explain to you what happened. So the problem is very simple. You try to type table something, but other function for creating a frequency, you are incorrect code. You see, this is the code I was having, and this is the correct one. If I copy this correct code, I'm going to get the result like this. They are trying to give you the sample output you should see. If I paste it here, and then I run, see what I'm going to see. This is the correct one I should get. And even you need to add a percentage, you see. Can you add percentage for us? You can say, for us, especially for all categorical variables. You see. Add some cross tabulation. So from there, you can proceed with asking more questions you want. And then it is going to, since you want epidemiological analysis, whatever, this is the patch screen and prepare categorical variables. You see everything where we have case when. This is the code we have run yesterday. You see, case when, whatever. It is using case when, and this is the way we did it yesterday. So it is cleaning now the categorical variables. Once you have done with this, you can come and copy this. If we copy, yeah, you see, those are the things you can continue to do, rinse, whatever,
With the graph. Is it-
you see. Those are all the analysis, actually. Those are the analysis you can do for them.
Sorry, let's see.
Yes,
So these are the analysis, and then if you want to get a report, whatever they want, you have to copy it, maybe in the Excel.
okay. Look at this now. This is the result AI has given me.
Okay.
I copied the result. Yes, this is a good question. I copied the result. Yes. Once I copy the result, I come on AI. Because first, when I'm making a report, I will need to put some numbers in a table, like a simple table. Yes? I come on AI, then I said, hello again, chat. Look at these findings. These findings here. I copied the entire findings. It is loading and give me,
You have copied already.
yeah, give me the statistics in tables. Yes?
Or in Excel.
In Excel. Why do you say?
Okay.
Let's have it first in table and then we can copy tables and then we paste it in Excel. Download. You see? Smoking. Okay. Give me statistics, please. Separately. Let's see. You don't need a code. You see, this is what AI can give me. It will depend on the way you interact with it. You see, I have age distribution, I have gender, I have smoking, I also have patient, I also have something like that. I can come and then I copy let me run the entire code so that I can have a good report. You see, I'm getting a good now. I can say I can copy this and then look here and update. And you're going to see the result you're going to see. You see, patient outcome. It is giving you the outcome, like the values, frequency, and their percentage, and even a sample interpretation. For each and every variable, it is trying to give you the variables, the observation is in a table, and also the sample interpretations. From there, that's where you can copy this result and then you paste it in a Word document. From there, you can, based on, like, you can do further analysis from there. If I copy this, maybe, and then I come on Word document, let's say when I come on Word document, you see, those are the findings I'm getting. I can read this one. If I come here on Word document, this is how the tables is coming from ChatGPT. So of course you have to click on this. We do some edit. If I click on this, something like that, you see. So numbers are going to go in a tables, and then you start doing some manual interpretations. Maybe the interpretations they give you, it is not clear. You have to do something you can do for your end. But at least you can come and then you click each and every, if you put here, double click.
It's true, it's not wrong.
Eh?
There is no hallucination.
Okay. So
My question is that if you use a ChatGPT,
yes.
you have to be prone to have hallucination.
No, like there is no like hallucination unless you provide full information, because even the interpretation they are providing here, it is based on the content I provided previous. Because when you look at the findings here, this is the outcome variables. You remember we was having it in our previous data set. It is also recorded as recovered, ongoing, deceased, and unknown. Unknown, they consider this as a missing value, maybe for example. And when you look at the interpretation, among 611 participant records,
Patient, not participant.
patient, 34% has recovered, representing the right outcome category, and further 27% were still ongoing, while the 27% were recorded as deceased. The outcome that was unknown is 13%. The observed mortality proportion was therefore 27%. This is ongoing. You see? And yes, how we generate this report? I tell AI to generate it, and then I copy, I paste it here. Yeah. This is where I put that kind of thing. This is where I copied from AI.
You copied what? You copied that one?
Yeah. I come on output. First, I come on output and I copy the output. I paste it in AI, and then I told AI to make a report for me. They did this for me. That
one you copied it to where?
Yes, I copied it and I pasted it in Word. In a Word document. I come here and then I said copy. This is a copy. Copy response. And then I come on Word document. You see, I can copy the input, like paste it here. things are going to come, you try to do some manipulations in a Word document. So, Benjamin, can you send them the questions?
Let's take a 10-minute break and they come back in groups.
Yeah, in a group. Yeah, we're going to work on a group of 2 people. Yeah. You want one? More than 2 people. 4. It's why.